Graphs provide us with a lot of different information if we know how to look at them and how to read them. In this first example, we have a patient who's hooked up to an IV bag in the hospital, which continuously is supplying medication to her bloodstream. The amount of medication in the bag, measured in milliliters, is recorded over a 12-hour period, and the information is displayed on this graph. So if you take a look, we can see that along the x-axis, down here, is where we find the time in hours that have gone by. And along the y-axis here, we have the amount of medicine that's been used over time. Looking at the graph, we can answer the following questions: how much medication we started with, how long it takes the bag to empty out, how many milliliters the patient is getting every hour, how much medication is in the bag at any given time, and when there'll be a certain amount of medication left in the bag. So how do we do that? Looking at the graph, how much medication was initially in the bag? So basically, no time has gone by. So when no time has gone by, and we look at the time in hours, that would be when 0 hours have gone by. So when 0 hours have gone by, if we follow up to where the graph starts, when 0 hours have gone by, there are 1,000 milliliters of medication in the bag. So there's our starting point there. That's the start of the graph. How long does it take the medication to completely be empty out of the bag? Well, now we have to look at where the graph, so here's our graph, where is there none left? So the numbers along the side here tell us how much medication is in the bag. So here's 0. This is where there's 0 medication in the bag. When there's 0 medication in the bag, the graph hits the time in hours at 10. So after 10 hours, the bag is empty. How many milliliters of medication are getting supplied to the patient every hour? Well, if I take a look, at the very beginning, the patient has 1,000 milliliters in the bag. Okay, so what's our next time? Our next time is 2 hours. At 2 hours, how much medication is in the bag? Here. At 2 hours, there's 800 milliliters of medication in the bag. So if I started with 1,000 and ended up at 800, that would mean after 2 hours, 200 milliliters came out of the bag. So I used 200 mils every 2 hours, which is the same as 100 mils per hour. So what about D? How much medication was in the bag after 4 hours? Okay, let's look along the time in hours. Here's the 4. We'll go up to the graph. Meets the graph at 600. There are 600 mils of medication in the bag after 4 hours. And when is there 400 mils of medication in the bag? Well, where's 400? Here is 400 mils of medication. If I go across to my graph and go down to hours, there are 400 after 6 hours. So it's 6 hours. There are 400 milliliters left in the bag. Why do we care about this? Why is this important? If you were a nurse or a doctor, you would have to know, okay, my patient is getting medication. After 10 hours, I need to change the bag of the medication. So this is a real-world application of why we need to understand and follow graphs. Let's take a look at example number 2. In this graph, a local trucking company is having trouble finding qualified drivers. And so as an incentive to attract new employees, they offer a signing bonus on top of the regular hourly wage. The amount of money a new employee can make in his or her first week is described in this graph. The money earned before deductions is on the vertical axis, so that's here. There's the earnings in dollars. And the number of hours worked by the new employee is on the horizontal axis. The number of hours worked, the earnings in dollars. And we can see here's the graph. The graph is going up from a starting point at 500. And the questions that we are going to answer around this graph have to do with money and how the trucking company is managing their money. How much is the trucking company offering as a signing bonus? So how much money is the trucking company offering as a signing bonus? Well, a signing bonus is what they're going to be making before they even start working. So before they've worked any hours at all, how much money are they going to make? So we look at the graph, and at the very beginning, when no hours have been worked yet, the graph is at 500. So the earnings are $500 even before they've started working. So the signing bonus must be $500 because that's what a bonus is. It's how much money you make on top of any other wages. So you're going to make $500 when you haven't even worked anything yet. So let's assume that we're doing a 40-hour work week. What's the most amount of money that the new employee can make? Well, let's take a look at the 40. So I can see here's 10 hours, 30 hours, 40 hours. Here's a 40 hours. So where is the graph at 40 hours? Here's the graph at 40 hours. At 40 hours, the employee will have made $1,300 at 40 hours worth of work. So the most amount of money that an employee can make in their first week is going to be $1,300. What is the hourly wage for a new employee? Well, let's take a look. In 10 hours, so from 0 to 10 hours, the employee goes from $500 earnings up to $700 in earnings. So in 10 hours, they're going to make, well, 700 minus 500 is 200. So they're going to make $200 in 10 hours. Well, 200 divided by 10 is equal to 20. So they're going to make $20 in 1 hour. If they make $200 in 10 hours, they're going to make $20 per hour, or $20 in 1 hour. So if a new employee only works 30 hours, how much can they earn? Well, let's take a look. Here's 30 hours. So in 30 hours, there's the graph, they're going to make $1,100 after 30 hours worth of work. Finally, if a new employee makes $900 in their first week of work, how many hours did they actually work for? So let's find $900. Here's earnings in dollars, and here's $900. So let's follow $900 over to where it meets our graph, which is here. So after we have earned $900, we have done 20 hours worth of work. So after 20 hours, we will have made $900. In our third example, Omar is getting some gravel delivered to his property. The company that supplies the gravel charges a trucking fee plus a cost per ton of gravel. That makes sense. You have to pay the truck driver, and then you pay for every ton of gravel that you get. This graph shows the relationship between the cost of the gravel and the number of tons of gravel that you order. So using this information in this graph, I'm going to be able to figure out how much the gravel costs per ton, how much I can afford to buy, how much Omar can afford to buy, how much the trucking fee costs, and we're going to take a look at how all that information can be found. The number of tons of gravel that you can order is found on the bottom, or the horizontal axis of the graph, and how much the cost of the gravel is found on the vertical axis of the graph. So if Omar orders 2 tons of gravel, how much will it cost him? Well, the number of tons of gravel is along the horizontal axis. Here's the 2. If I follow the 2 up to where it meets the graph, the cost is going to be $80. So for 2 tons of gravel, it will cost Omar $80. If he has $140 to spend on gravel, how much gravel can he get? Well, here's $140 in the cost. Let's follow it across to the graph. Where it meets the graph, follow it down to the number of tons. And for $140, he can buy 4 tons of gravel. So what do you suppose the trucking fee is? The trucking fee is going to be what you pay the truck driver no matter how much gravel he brings to the house. So even if the truck shows up empty, you still have to pay the truck driver, and that's going to be your trucking fee. So let's say you ordered no gravel, but for some reason the truck driver came anyway. Here's no gravel, but the graph is already at $20. So the trucking fee must be $20 because it's going to cost you $20 for the truck to show up, even if there's no gravel in it. To figure out how much it's going to cost per ton of gravel, I have to look at how much it costs as the amount of gravel I order increases. So when I ordered no gravel, it was already going to cost me $20. When I order 2 tons of gravel, it costs me $80. So the difference between no gravel and 2 tons of gravel is $60. So it's going to cost me $60 difference between no gravel and 2 tons. So if I divide 60 by 2, it's going to be $30 per ton of gravel, because $20 is the trucking fee. So $60 is what it cost me for 2 tons of gravel. So $30 is how much it's going to cost me for 1 ton of gravel. If Omar needs 7 tons of gravel, well, I could do 7 times 30, and 7 times 30 is $210. And then I would still have to add the trucking fee, which was $20. So I would know that it would cost me $230 altogether, because if it's $30 per ton times 7 tons, that's $210. The trucking fee is $20. 210 plus 20 is $230 to order 7 tons of gravel. So even though 7 tons of gravel does not appear on the graph, I can still answer the question because the graph tells me how much I have to pay to start, or how much the extra fee is, like the trucking fee, and it also tells me how much per ton. So I don't need the whole graph when the graph is a straight line.